Okay. A warm welcome to one and all. Thank you for joining us for the soon to happen enlightening discussions on NSM infra, application and user experience, which will be followed by not to miss sessions by our CDACians who will be sharing their experience as an expert. As we know, the National Supercomputing Mission, NSM, had made significant stride in building a robust HPC ecosystem across the country. Today's sessions brings together esteemed users and domain experts who will share their first-hand experience, insights, and challenges in leveraging NSM infrastructure for their scientific, academic, and industrial applications. This panel discussion brings together key voices from Indian HPC ecosystem to explore the evolving landscape of the NSM, its journey from the inception to its future roadmap. Chaired by Sri Sanjay Vandekar, who heads the mission at the CDAC, the session will delve into NSM foundational impact on creating indigenous supercomputing capabilities and enabling national importance applications across sectors. May I request the panelists to take their seats. We have with us Sri Sanjay Vandekar, Professor Abir De Sarkar, Engineer Mohammad Faiz Saeed, Professor Animesh Kule, and Dr. Saket Ram Trigula. A round of applause, please. Thank you and welcome. Sri Sanjay Vandekar, a key contributor to India's supercomputing journey, in his current role as Center Head CDAC, Pune, Mr. Vandekar is spearheading several projects of national importance like NSM and remains deeply involved in the development and implementation of several cutting-edge technologies. Moving on to our next panelist, Professor Abir De Sarkar, former Dean Academics, ACSIR Coordinator and Dean Faculty, Institute of Nanoscience and Technology. His research expertise is in 2D materials of engineered energy and electronics using DFT-based approaches. He has been awarded for excellence in nanos research for the year 2018, and he is also recipient of President of India Medal for the year 2000. Next, we have the pleasure of introducing Engineer Mohammad Faiz Saeed. He is currently Director, Flood Control Application, CWC, New Delhi, and heads the flood modeling team of CWC. An IES rank holder and a recipient of Best Researcher Award in Disaster Management, mainly looked after the work of survey and investigation monitoring and appraisal of various irrigation projects in the northeastern states of India. He played a key role in development of water sectors in these states. Following that, let's welcome Professor Animesh Kule. He is an associate professor in Department of Physics at an Indian Institute of Science, Bangalore. Dr. Kule's research focuses on theoretical and simulation studies of fusion plasmas and high-performance computing. His research group, the Kule Group, is developing a global gyrokinetic code using cylindrical coordinates G2C3 for India's domestic fusion program in collaboration with CDAC. Equally distinguished is Dr. Saket Ram Trigula, who is a highly accomplished individual currently serving as a research officer Ayurveda at the CCRAS National Institute of Indian Medical Heritage, Hyderabad, under the Central Council of Research in Ayurvedic Science, Ministry of Ayush, Government of India. He has made significant contribution to the field, particularly in the integrating information and communication technology solution in Ayush system. Panelists will share insights into real-world HPC applications, user experience with NSM-enabled infrastructure, and the strategic importance of HPC in the areas such as climate modeling, drug discovery, and much more. This discussion aims to reflect on how supercomputing is shaping India's digital and scientific future. May I now request Sri Sanjay sir to kindly brief and initiate the discussion. So please.
Good afternoon all. Am I audible to the last person there? Yeah, good. So little bit brief about what is National Supercomputing Mission. I think some of the members here are, I think, may not be aware of what is National Supercomputing Mission. So this is a joint initiative of MIT and DST. and started way back in 2015-16. And the implementation agencies are CDAC and IISc together. So these are the two implementing agencies implementing this mission. And there are 4 pillars of this mission. One is creation of infrastructure and of supercomputing systems within the country. Then there is the next one is basically NSM R&D, where we actually develop the various technologies which are required to develop the supercomputers. And third one is basically NSM applications of national interest. And fourth one is basically the training part, that is HR part, where we are training the HPC manpower in this. So under the first pillar, which is NSM infrastructure, till date we have actually established about 37 supercomputers with a cumulative capacity of about 39 petaflop of compute power. And we are actually targeting about 90 petaflop within I think another 9 to 10 months with 20 petaflop national facility in this mission. So the work is ongoing on this, and there are many users who are using these systems. About 10,000, about 12,000 plus researchers are using these systems, and 2 of them are here to share their experiences on the systems. And about 200 plus institutes, these researchers are across the 200 plus institutions. Under NSM R&D, basically to develop these systems, we have developed various technologies. We have a talk in after this panel session about what are the technologies we have developed. Mainly the servers, system software stack, and network. These are the part which is developed under this. And we are also developing processor, which is going to be 96 core ohm processor under this mission. So with these technologies, way back in 2014, our indigenous contribution to this supercomputing system was about only 10% to 15%. Now with these developments, our Param Rudra, which is recently inaugurated by Honorable Prime Minister, 3 systems of them, which is having about 50+% of indigenous content. So with this, some of the highlights of this NSM systems and basically the ecosystem which is created under NSM, there are some highlights I would like to say here. One of them is we have actually specially engineered one system for giant meter wave radio telescope, which actually processes the real-time data from radio telescope which is there in near Pune to search fast radio burst and pulsars, leveraging the capabilities of GMRT for cutting-edge astronomical research. So this is one thing which is basically supercomputers are normally used for simulation and modeling, but here basically we are processing the data real time. So this is one of the achievements. Another thing is we have developed indigenous ecosystems of partners where we can actually design and manufacture the HP systems and their components. So we have some technology partners, technology transfer partners for our Rudra servers. They are actually our manufacturing partners, Vividian, Keynes, and Avalon. These are three of our manufacturing partners. We have technology partners. These are international partners like Intel, AMD, NVIDIA, DDN. So these are again supporting us in this mission and future our endeavors. We have system integrators like NetWeb, Micropoint, Concept, Locus. These are actually helping us in integrating all the systems together and putting it together. We have data center partners, Schneider, Vertiv, Orion Pro, Grid to Chip, Nikon, Prasa. These are some of our partners who have helped us, and actually because of all these partners only we are actually able to deliver the systems, and we are going to deliver the systems. On the application ecosystem side, we have various partners from academic institutions like IITs, ISCs, research institutions, user agencies like CWC, IITM, IMDs. municipal corporations, ONGC and so on. These are our partners. Then again, there are other line ministries in they are also our partners in these NGOs. So under these applications also, we have CWC here. They will talk about the flood-related developments what we have done. Then we have done some work in the bioinformatics where Ayurveda is being used. So I think our partner here, they will be explaining how HPC is helpful in basically Ayurveda research. Then we have urban environment where we have actually done, we have developed an application which actually gives insight into urban floods, air pollution, heat wave, rainfall prediction, and this is getting implemented in some of the few pilot cities. Another thing is we are also into AI, where we have we are giving the access to the users for our Param Siddhi AI system, which is 410 AI petaflop with 650 plus GPUs in this system. So this is being used by startups, MSMEs and researchers. So with this, so we have 4 distinguished panelists here with us. 2 of them, as I told you, they are the users of NSM systems for their research work in various domains, and 2 of them are our end users of HPC applications developed under this mission. So I request each of the speakers to share their experiences and how their domain is getting benefited because of this supercomputing ecosystem developed under this mission. So with this, I think I can start with our first speaker, Engineer Muhammad Faiz Syed here to share his experience. Thank you.
Good afternoon, everyone. Thank you, sir. First of all, I would like to thank CDEC and the organizers for inviting me to express my views on the applications of NSM and high-performance computing. I'm from CWC, currently working as director in flood control applications. Basically, you can say that all the modeling work that is being done in Central Water Commission is currently under my supervision. So just to give you a brief account of how things developed over the period of time in this area of flood forecasting. As you all know that Central Water Commission is the nodal agency for issuing flood forecast in the country. And this practice started way back in 1958 when our first flood forecasting station was established in here, Delhi only, at Old Delhi Railway Bridge. And from there onwards, we have evolved and developed our FF network for the entire country. From one station to currently, we are having around 340 stations, flood forecasting stations spread across all the major river basins in the country. So this is how our flood forecasting network has developed over a period of time. But we have been doing this flood forecasting on a very conventional approach. Like we used to do gauge-to-gauge correlation, where, as you can imagine, we try to establish a correlation between upstream and downstream levels. And once that relation is established, once we know the upstream level, we can easily predict the downstream level. This is the methodology we used to follow. This is a brilliant and very effective methodology, and it has a very high success rate, but it has got a very serious drawback from the disaster point of view, disaster management point of view. The first is that it restricts and fixed, it has got restricted and fixed lead time that it offers. Like the travel time of flood from upstream to downstream is the only time that is available for the disaster manager to take preventive actions. So you don't have any control on that time. Secondly, the second major drawback with this system is that it does not give you any information about the inundation extent, the flood extent, where it is going to cause the disruption. So these two inputs are vital when we talk about disaster management. So to overcome these two drawbacks, in 2016, CWC modernized is all flood forecasting activities. Like we modernized our data acquisition system, we modernized our data transmission system, and the result of that was that in 2016 we were able to switch to mathematical based flood forecasting system, which was based on rainfall. So the 1D model were developed for entire India. 19 models we developed, and we completely automated them to get the forecast for all the 340 stations that we have. So the first problem of lead time was solved. But then the second problem was still there. That was about the flood inundation extent. So most of you must be knowing that if you want to calculate the flood extent, then you need to go to 2D models. 2D means two-dimensional models. Now the basic requirement of two-dimensional model is that you need to use DEMs, digital elevation models. Also again, one very important requirement is that if you want to have your predictions and forecasts to be accurate, then your DEMs should be of high resolution, because working on low resolution DEMs will not serve the purpose. Now again, the same problem comes that when you are dealing with 2D high resolution DEMs, then the power of compute comes into picture. And this is where we lagged in Central Water Commission. The normal laptops and PCs and even the workstations that we work on are not able to handle the kind of computation power which is required to process the high resolution DEMs. So this is where we thought of collaborating with CDAC way back in, I think, 2016, 17. I exactly don't remember but since we had purchased the Mahanadi Delta Basin high resolution DM, we thought of collaborating with CDAC and give them this work of, because availing their services of high performance computing. And I think it worked very well. Now it's the time to enjoy the fruits of that activity. And I think the model that has been developed by CDAC is working excellently. And I have been told that the entire 11,000 square kilometers of area of Mahanadi Delta that they have modeled, the entire simulation time is only 1 hour. It's incredibly fast time, let me tell you, because if you think of doing the same simulation on our regular PCs and even workstations, it will take days to run that model. So I first of all congratulate CDAC of successfully implementing this 2D real-time inundation modeling, which is, I think, for the very first time done in the country. So very, very congratulations to them. Secondly, what I want to say is that the results that we have been obtaining from this model are very encouraging. And I'm also of the view that with subsequent runs, it will improve drastically. I was just a few minutes ago, I was talking to one of their developers. He said they are now reducing the time of simulation. We are working hard to reduce the time of simulation. And if that happens without compromising the accuracy and the efficiency of the model, it will be great. We at CWC are looking forward to replicate this exercise to other basins also. And this is just the start of the beginning. It is just a start of the collaboration between CW and CWC, and we look forward to carry it in the future also. Thank you.
Thank you, Engineer Mohammad Faiz Said. Next one, I think I would like to request Professor Sarkar about sharing his experiences. Thank you.
Yeah, thank you, sir. Good afternoon, everyone. First of all, I truly appreciate this opportunity to be here, to speak here on this very important occasion. Tec-Verse 2025. And at the very outset, I would like to extend a profound gratitude to CDAC Pune and NSM facilities for their continued support and strong support since November 2014. On behalf of my team, I would like to sincerely thank CDAC Pune. So I'm very closely associated with CDAC Pune since November 2014, and I'm not an HPC specialist. I'm into scientific computing. I'm a professor. We pursue research on two-dimensional materials for energy and electronics, as it was announced by Dr. Shweta Das. But however, we have utilized the HPC systems very efficiently. We would like to share a few numbers in this context. With your great help and support, we have been able to publish 76 papers since November 2014 by utilizing your facilities on Param Yuva 2, Param Shivai, and Param Smriti. And I have guided 10 students to the completion of their PhD, and my scholars, they have sincerely thanked CDAC Pune in their PhD thesis. So these, and so this is how the group alumni, they are well placed upon the completion of their PhD. So I would like to share the journey. I mean, I joined the institute in 2014, in March 2014, as an associate professor there. And then I started to build up my group, and I found CDAC Pune, and I gradually became aware of the Param Yuva 2 compute cluster, compute system. And then I had applied for an account. I think the November 2014 is very well etched in my memory. It's very fresh in my memory, because very promptly, the response was very prompt. Almost in no time, the account was created, and the help desk has been amazingly supportive. And so we use these quantum mechanical based approaches, such as the density functional theory, as implemented in WASP, Quantum Espresso, Gaussian, and several other codes. And WASP is not a software which is freely available for academic purposes. So we had provided the WASP software to the Param Yuva 2 help desk team. I mean, this software we had purchased at our institute, and very promptly, very rapidly, the software was installed on Param Yuva 2, and then we were able to use it. And from time to time, whatever problems we had experienced, we wrote emails to the help desk team, and they responded with great promptitude, even at Param Shivai as well as Param Smriti. And few names I would like to mention here in this context: Pankaj Dorlikar, then Chittaranjan Singh, and Sri Ashish Ranjan. They have been particularly very supportive of me and my team. And upon joining, as I mentioned to you, I joined as scientist E. Then I have got 2 promotions, F and G. In summary, I owe all my successes in my independent career largely to CDAC Pune. CDAC Pune has played a significant role in my career, as also in the career of my scholars. And all the recognitions and awards which have come along since 2014, like I have been recognized in the top 2% scientists worldwide. So the credit also partially goes to CDAC Pune and the NSM resources. And whenever we needed help, say for example, Phono 3Pi, if we have to install it, any scientific tool which is required for the pursuit of research, the help desk has always responded very promptly. And so what I would like to add here is that, I was wondering if it would be possible for CDAC Pune to provide some funding support to us to boost our research further, say in the form of, say, JRF, SRF, or suppose we need some software, say upgradation of this Vienna ab initio simulation package or something, right? So, and then certain systems we are able to use on a non-chargeable basis for some time, and then it becomes chargeable, which is a bit difficult for us. So if you could also take that into consideration for performing users, like some of us. So I mean, as I mentioned the number, 76 papers we have published till now, but still many more to come. So And CDAC Pune has been a partner with us in our journey and career. I think that's all I would have to say. Thank you very much for your strong support and help.
Thank you, Professor Sarkar. Well, I would like to get some few specific examples where HPC accelerated breakthroughs in your nanomaterial research.
Say, like for example, I mean piezoelectricity actually. Piezoelectricity, we could induce piezoelectricity in some 2D structures where inversion symmetry was originally present. And after breaking the inversion symmetry through the formation of Janus structures, we were able to induce a high out of plane as well as in plane piezoelectricity. And that paper, which was published in 2018, has received a large number of citations. I mean about 250 or 300 citations. Now I'm not able to remember. And that is the reason my students, they have been able to find very good postdoc positions overseas, and they are all very well placed after completing their PhD. This is one such work, and then our paper published in nanoscale that was also recognized as the editor's choice, and several such publications. The list is a bit long, so I have to cut it short.
Thank you, thank you. So next one is our another user who is working in the fusion plasma research, Professor Animesh Kule. So I'd like to ask him to share his experiences of NSM ecosystem.
Thank you, Sanjay ji, and thank you the entire CDAC team for inviting me. So after so let me tell you like briefly in a simple way what I'm doing. So you all know that we are all looking for some kind of a clean energy challenges, because all the energy that presently that we are using, it's mostly creating a lot of pollution. In people who are in Delhi, they are very familiar with this issue. So there was a big effort going on that can you bring the sun energy, right? Create an artificial sun in the world. So this is basically all the energy that produced in the sun is basically during the fusion process. So the effort is like that, can we create some kind of reactor where you can create the fusion and extract the energy. And the biggest advantage is that this is there is no radioactivity and other things. So it's absolutely clean energy. See, one of the bigger challenge in doing that one, see, fusion is not a very difficult thing to achieve in the lab. But the bigger challenge is that can you control it for the longer period so that you can extract the energy from the system and send it to the grid. So this is the major challenge. So now all the international community come together and trying to solve this problem. And one of the major issue with this one is called the turbulence and the transport. So there's a lot of instabilities, as you can see in the sun of fossil. We have seen a lot of energetic particles are coming out, all those videos and other things. Similar things happen in the fusion reactor also. So we want to design much more optimized reactor where you can control the fusion for a longer period, and eventually you can extract the energy and send it to the grid. So, the work that I'm doing with all the international collaborators is like trying to find a better way of designing these machines so that you can control this fusion and you can sustain it for a longer period so that you can get the energy which you can send it to the grid for the electricity purposes. And so if you want to carry this experiment, so running each experiment costs like millions of dollars. It's extremely expensive things to run those things. So now because of the supercomputing facilities, now we have the capability to predict all those things. So before doing the experiment, we can tell what is going to happen, how much energy you are going to, what kind of instabilities are there. So this needs a dedicated, large computing, and you need to model the machine very accurately. So that's why you need a very, very large computing resources. So, when I was abroad, we have these big facilities in Oak Ridge and others, so we can use those one. After coming back to India, I work mostly in the Param system, like Param Prabega in ISC Bangalore. So there is a lot of challenges over subscribed machines, Then we started working with this Pune team, CDAC, we approached to Sanjay ji that there are some issues, so how we can handle it. And there was another one in thing is like, this field is highly classified field. So people don't share these codes until you have a good connection with them. So the major things that we tried in our group is like this, developing those codes indigenously in India. So we work with our Indian partner. It's called Institute for Plasma Research in Gandhinagar. So they have 2 fusion reactors. So we work closely with them and develop the entire code from scratch at IISc Bangalore. So then, we have this challenge of checking the scalability of those code, because we are not able to do this in Parampravega in IISc. It was oversubscribed. So with the help of Sanjay ji and his team, Sweta is here, like a lot of other people are here. So we got the access of this, this Rudra machine, which recently they have developed in IIT Mumbai. So we luckily got the machine for 2 weeks. So we extensively use it, and we found the scalability is very good in our code. So now we are going for the bigger machine so that we can really predict those things. And another one important things that we did, in these days, AI become playing a very important role in all those fields, irrespective of physics, chemistry, biology, whatever are these, even weather predictions. So we thought use the same idea that, currently these codes that people are using are extremely expensive to run. So some of them, even the US, people are running an exascale machine. Right, but it takes still a couple of days to achieve those things. So now the effort is going on, like, can you replace some of the modules or the things by the AI-driven kind of thing? So what we did in our code, one of the major part, like, which was taking the major part time of the computing, we replace all those things by our indigenously developed AI models. So now it's very easy to run those in bigger, scalability wise, testing wise, and even you can match those results with the experiments also. That is a remarkable things, and because of the CDAC dedicated help, we are able to do it. And we really need their continuous support in terms of this, availability of the resources as well as the new machines. And, CDAC is going towards this exascale computing. So one of the important things that we need really help, you think about all the codes that we are developing is good for, say, 20, 50, or maybe 100 petaflop machines. So like the parallelization and other things that we have. But if you think about when you are going to this exascale kind of things, you need dedicated modeling also, so that you can differently parallelize those. So, and you also need some help to analyze this huge data. So I think those kind of things also we need to develop, work with this CDAC team so that we can predict those things in real time. Because, without that one, this will not help much. So this fusion is a very old field. If you see, already people are working on this for the last 50 years. But, in last 5 years, there was a remarkable achievements happen. And it's because it's driven by the supercomputers. So we know what kind of design you want, what kind of tiles you want, what kind of power you want, how you model accurately. All those information you have in hand before you're doing the experiments. So I think we need to work with this CDAC team dedicatedly with all these new machines coming, so that we can parallelize our code, do the real-time scaling, and case studies, and support our own domestic fusion program. Because at the end of the day, this technology has to be developed in India. Nobody is going to share with us. So we are really thankful to CDAC, right? For till now, whatever the major things that we are able to do in IISc is because of their help. So thank you, CDAC. Thank you, Sanjay ji, for your help.
Thank you, Professor Animesh. So next one is Dr. Saket Ram Trigula. I think he should share his experiences of whatever applications we have developed in the bioinformatics to help Ayurveda to be the mainstream medicine. Thank you.
Thank you very much, sir. So actually our journey with CDAC is quite old. In fact, way back in 2006, there was an application called IUSoft. That was one of the early applications. It's a decision support system and a Prakriti analysis system that was developed long back. But recently our association with HPC group, Udvesh sir and sir's group was during the pandemic. So actually we were searching for somebody who could, actually we have a proprietary medicine from CCRS called Ayush 64 that was actually developed for malaria long back in 84, but that's equally useful in influenza-like illness. We had some case reports just before pandemic. One of our colleague was documenting it. So we were curious to try that, because pandemic, many people were trying for possible candidates to get some succor, some help. So initially we worked with National Institute of Nutrition, Hyderabad. So they could come up with initial leads that it is effective against this like ligand, and it was able to neutralize that, and that was the first lead. So with that we went to ministry, and there was a committee which was deciding on the candidates to go for some trials and other things. Then the Omicron variant came, and at that time I think this team has helped with their very short time on a phone call without any formalities. They took up the study and they completed it in a very, very short time, and that helped us convince our higher officials to take it for in vitro and as well as clinical trials that is completed, and it was actually given for distribution. I mean, this was one of the very quickest turnaround times for any medicine to be completed, all the kinds of possible studies, and was also distributed for prevention, as a co-medication with mainstream medication, and that has prevented a lot of deaths. That's one of the very satisfying journeys with CDAC. And we continued with that. In fact, we have a intramural project between Council and the HPC, this group which works on bioinformatics. They are currently working on 3 candidates, 3 compound formulations, hypertension and a couple of other conditions, and they are helping us understand the mechanism. See, the problem with Ayurveda is that the medicines work, but we don't know the mechanism. That's the biggest challenge. And another complex is most of them are the concoctions. They are not let alone single chemical. They are combination of multiple herbs having multiple chemical moieties. And probably that was one of the reasons why no pharmaceutical industry or nobody ventures into it, because of the complexity involved. So it was left out like that, but thanks to the computational ability now we have. So for example, the current work which is going on with this team, it has 135 chemicals from 4 plants, and they could come up with very good possible like docking scores, but that is one part of the story. Now the story is like one-to-one kind of a ligand like docking we can do and predict whether it has some effect or not. But the complexity is where we have the problem statement is that what is happening with this 6 or 7 chemicals, what is happening between them, and how they are interacting with the host, and what is the eventual outcome of it. I mean, it is not addressed nowhere in the world. The problem has been addressed. Chinese are trying a bit, but they are also far away from that solution. Probably we can take lead in that domain, and probably we can come up with a model, at least a computational model, to simulate that biological system vis-a-vis the whatever the chemical or say mineral moieties which we are introducing into that system, and how it works. Clinically it works, sir. In and out, I'm an Ayurveda physician myself. They work, but we need an explanation for that to get little more validation. Of course, we are not waiting for that, but that gives us a larger acceptance. And another information I want to share, another application which is developed by CDAC for Ministry of Ayush and CSIR is the Traditional Knowledge Digital Library, TKDL library. Of course, the purpose of TKDL is to prevent like wrong patents which are based on Indian traditional knowledge. But in the process of it, last 20 years between Ministry of Ayush and CSIR, we could document 450,000 plus formulations. It's a humongous data. And if we are able to process that scale of data, we need a huge computational facility to do this. Probably that's also going to be, I'm also working with closely with this benchmarking of AI for traditional medicine with ITU, WIPO and WHO. There is a global initiative with them. There also we are showcasing these examples. So, thanks to Government of India's latest initiatives, we could also, like for example, now we are the donor country for WHO in a couple of major projects. One is standardization of terminologies in Ayurveda, Siddha and Unani, which is very important because most of it is in Sanskrit or some other language. Other colleagues, like for example, scientists or engineers will not be able to understand, or say modern medical doctors, for example. So we are filling that gap from the ministry side. But when we collect the data, for example, recently we could add Ayurveda morbidity codes in the World Health Organization's International Classification of Disorders. That's a major achievement for us. That's the 11th revision which has happened after 30 years. So the Chinese medicine was added, but we worked hard 5-6 years from 2016 to 2000. This year it was released. Thanks to the leadership of ministry and also Honorable Prime Minister, we have a portal called National Ayush Morbidity and Standardized Electronic Terminologies portal. So we are trying to fill up the gap on the semantics and also the terminology part. And now we are going to collect a lot of data from the field, and we are going to implement it through a electronic health record system. But to process the data, we need a very good computational ability. So these are some of the use cases. Apart from that, of course, we work in the other domains also. For example, material characterization. We use a lot of minerals. I mean, the so-called very toxic mercury, we use it in and out in large quantities as a medicine. So how to study? I mean, maybe we don't know. We don't have any data about that. I was seeing CMET works on this kind of like when they recycle the material, they're also collecting these rare materials. I was going through the literature, so they ensure that the mercury level is very, very less. But we have a counter story here. We give mercury to people to eat in a mercury sulfide form, of course doing all of that standard processing of Ayurveda. They do not cause much of a problem unless it is done in a very bad way by some stupid manufacturer. But how to establish the safety, what exactly it is doing, we don't have any data. And to do that, I think these computational limitations were there. So from the ministry, we are ready to venture, but we need good partnerships from various domains, interdisciplinary domains, where you can pitch in and solve these problems. Sir. So these are the few things I thought I will share with the audience and take your guidance to take this mission forward. Thank you so much. Thank you. Namaste, sir.
Yeah, thank you, Dr. Saket. I think floor is open for questions to the panelists.
Thank you. Hello. Thank you for your. So I have few questions from my scientific curiosity. We have listened that we have 19 models for flood modeling. So are these 19 models different in which respect? Can be these one of these models can be suitable to a specific river or specific location, or these can be adapted to other places?
Actually, the 19 models that I talked about is in-house system built by CWC. It's based on 1D models where we completely automated the system of downloading the rainfall data and then injecting into the model and then running the model in series and then finally getting the outputs. This is a system which is already in place. We call it a 7-day advisory flood forecast system. If you want, I can share the URL also. You can see there. So it's a 1D based model where prediction up to 7 days is there. So it's a very robust system, and we have been executing this model since 2016.
Sir, my question was that whether this model is a location specific thing or can be adopted anywhere?
No, it's a location specific. I told you we have 340 stations, flood forecasting stations, spread all across the country. So for every point we have a model. Yeah.
No, one question from my side is how this CDAC developed model and how it is actually it can be used, and it can be used across the various river basin. Whether it is any changes are required in this or same model can be used.
Yes, sir. So our experience with this Mahanadi basin has been very experienced learning. Since we had purchased the Mahanadi high resolution DM in 2016-17, but we are not able to process it because of the limitation of the compute. So we approached CDEC for this, and from there onwards, I think the journey has been very two-way and interactive. You had some problems, we had some problems, we came together and we solved the problem. So this is the kind of mode that we would like to take forward also and replicate the same thing to other basins also, because in India we generally have basins of the scale of more than 10,000 square kilometers. We don't have small basins here. So the requirement of 2D modeling will definitely require HPC services. We cannot ask to get it done through our laptops or PCs or even workstations. So supercomputing is the must requirement if we want to generate real-time 2D flood inundation maps or flood forecasting. So I think we will definitely would like to replicate to different other basins also by mutual consideration. Yeah.
Yeah. Any more questions? Before that, I think he would like to say.
I just want to add one point, sir. In fact, I was supposed to tell a couple of points about the bioinformatic initiative. We also worked on one plant called Shonak, Oroxylum indicum. And we have seen there was one case paper published in Bora Medical College, Assam, about complete remission of nasopharyngeal carcinoma in one person. So based on that one lead, we have requested the team to see, and we have found at least 4 molecules which were doing multiple works with respect to that particular cancer, at least in the bioinformatic model. They were able to reduce the tumor size, the responsible proteins, they were effectively stopping that. They were also able to actually work on those pathways where the metastasis was also possible. So one plant having multiple uses, and I must tell you, there are many candidates for like blood cancer and especially the liquid cancers. We have very good candidates, but in solid tumors we don't have many candidates. In herbal domain, I think this is one of the possible leads. Probably we can work on further and take it further. So that's the power of computational explanations we are getting today. So now I'm confident as an Ayurveda physician. When I say Shonak works, now I have a little bit of explanation. Of course, I will further run the trials or in vitro and rest of the things, but now I can go to any team and convince based on this data. So that kind of a power is what we are trying to envisage, sir, from this facility. Thank you.
So Dr. Saket, how do you see from the regulatory perspective, like taking this molecule from the phase 1, phase 2 and phase 3 trials, because there are so many components in that, how they are interacting, what their toxicity, how are you going to take the challenge of that?
Sir, it's in 2 ways, sir. As far as regulation is concerned, if it is an Ayurveda medicine processed as per the Ayurvedic methodology, so we don't have much of a regulatory hindrances. Only thing is, as I said, we need an explanation to convince the larger audiences. And as far as the safety is concerned, it is already, if the formulation is already in use, the safety is assumed that it is available. But as you rightly pointed out, if it is a new if I am isolating a couple of molecules from that, so I have to go through the same process to that of anything. And now CDCSO has introduced a very nice category called phytopharmaceuticals. So it is legal now. A few years back it was not available. Either it was a herbal Ayurveda drug or some other or it was not existing at all. But if somebody has a plant where they can have 4 biomolecules which they can establish the safety and efficacy and which is not earlier reported, if it's a new new observation or new utility, we can apply under the new drug as a new drug entity as a phytopharmaceutical, but the process is the same. It's the same in vitro, in vivo toxicity as well as phase 1, phase 2, phase 3 clinical trials, and then we can get the license for that.
So you can separate those components very easily?
It depends on the context. It depends. It depends upon what you are dealing with. Preferably from Ayush side, we are not going to venture into that right away because that's a very long, laborious route. But the low-hanging fruit is that we already have an established medicine which we are prescribing. So if we are able to get an effective explanation and like replicate in the experimental model, that is sufficient to at least start using it. And based on that feedback, we can go for a bigger one. You see, the advantage is that, sir, we are buying a lot of medicines from outside. I mean, and we are paying a lot of royalty and other things. But this will bring us a great possibility to have indigenous molecules having a lot of therapeutic potential, especially in the rare disorders or say certain types of cancers and other conditions, where India can actually discover the drugs in a very quick time. In few years back, it was not so easy, but thanks to this computational capacity, our time of iterations will come down drastically. And that will save a lot of energy and time, and then we can plan rest of the things.
Thank you, Dr. Saket. I think due to time paucity, I think we should conclude this.
Sure, sir.
Yeah.
Yeah, thank you, audience. Thank you for such an overwhelming and interactive response. Let us put once more a big round of applause for the panelists for sharing their experience. Trust me, sir, these small experience sharing inspire us so much that it meant us to give more and deliver more as a team. So, few of us might be face of the support and collaboration, but completion would not have been possible without a team. Taking an opportunity, I would like to applaud all the team members who made this happen. We extend our heartfelt thanks to all the esteemed panelists for sharing their valuable insights and experiences on HPC applications and the use of NSM infrastructure. Your perspectives have greatly enriched the sessions and offered meaningful takeaways for the entire audience. We truly appreciate your time, expertise, and contribution. As we reach towards the end of the discussion, as a token of gratitude, I would like to request Sanjay sir, yes, to give a memento to Abhirde Sarkar, Dr. Abhirde Sarkar. I would again request Sanjay sir to hand over the memento to Dr. Saket Ram Trigula. Next, sir, please hand over the memento to Engineer Mohammad Faiz Saeed. Last but not the least, a token of gratitude to Professor Animesh Gule. I would like to thank you all, thanks all the panelists for sharing their experience. Thank you all. We can conclude the session. Thank you.